some of all these data structures concepts, and I hope that is something that you can learn from. We're not writing any code or solving any algorithms problems or anything like that. This session is more an explanation of the different kinds of data structures that exist and how you can use these data structures, how you can apply these data structures in real world apps and things like that. So I'm going to go ahead to share my screen now.
Oh, also, Adora, really sorry to cut you short, but is there like a possibility we get to see your face? Yeah, I want to see your fine face.
Unfortunately, no. This place is really dark at the moment, so my lighting isn't great. I'm not in my office, I'm in my room. So I didn't know this earlier. I would have gotten ready for the session in a way that would allow me to do that. But
Oh, okay. I mean, that's fine as well. I think maybe some other time the learners gets to see your face.
Okay. Please give me a second.
Yeah, sure.
I might need to leave Zoom and come back because of this is a new computer sharing my screen. So apologies, give me a minute. I'll be back now.
Oh, okay. Okay. So guys, really sorry for the delay. Yeah. So Adora said she sent a mail. To be honest, I did not see that mail. I really did not see that mail. I would have like informed us that, oh, she'll be coming in like a few minutes late, right? But I did not see the mail. So, but again, apologies. All right, apologies. She actually sent another mail, but that was like about 5 minutes ago, and I was, busy trying to reach her some other medium that I did not put my attention on checking my mail, right? So, yeah, really sorry about that.
Okay, I'm back.
Yeah. Awesome. Okay, let me give you the rights to share your screen again.
Okay.
Understand. Zoom, don't. Are you okay? What's going on? Still trying to. Okay. Okay, got it. Okay, you should be able to share your screen now.
All right, let me try that. I can.
Oh yeah, awesome.
Thank you.
Yeah.
Yes, I think I'm just going to share.
I can't
share screen because for some reason I can't share like particular Chrome tabs. So let me know when you can see my screen, please.
Yeah, we can see your screen now. We can see the slides now.
Okay. Lovely. So yeah. Hi everyone. Like I said, we're going to be talking about data structures today and their real world applications. It's raining over here, so in case you can hear like background noise, it's the rain. Please try your best to ignore it. Thank you. I'm gonna go straight to an introduction of myself. Thank you so much, by the way, for that introduction. I don't think I have much to say at this point. I'll just say that my name is Adora. I am a software engineer and an author, and I'm also a digital creator. I work at Microsoft today where I build mixed reality on the cloud. And I have grown to become passionate about teaching the fundamentals of computer science, data structures, algorithms, systems design, and things like that to people, because these are things that you not only need to get into these roles, but you also need to keep these roles. I know I say lots of things on social media where people say you will suffer and learn how to build data structures and algorithms, and then when you enter the company, you are changing the color of a button. I'm sorry, but that doesn't happen to me. I work in mixed reality and building the metaverse. If I do not really know a bunch of all these computer science fundamental concepts, I would have probably gotten fired at this point. I think it's something that is very important. And I've realized that it's something that not too many people have gotten the opportunity to know about. So I want to help as many people as I can learn about it, which is one of the reasons why this is what I am talking about at this session. And I hope it's useful to you. So yeah, I already kind of talked about me getting into Microsoft and how data structures, algorithms and all these computer science fundamentals are a huge part of that. I think that they're a huge part of starting your career in different tech companies. Many tech companies would always ask you about these concepts before you get in, whether you're getting in a junior capacity or as a senior or principal or staff capacity. Like, there are just some things that they expect that and the fundamentals of computer science is one of them. I graduated from uni in 2017. I think 2017 December. At this point, I'm not sure anymore, because even my convocation was May 2018, but I know I wrote my final exams October 2017, but my certificate says 2017 December. So I think that's when I graduated, even if my convocation was a couple months after. After that, I was working in an agency as a software engineer for a bit, and then I joined Microsoft a year after. So I did NYSC. So throughout my NYSC year, I was working at that advertising agency. I was, coding for them and also doing a bunch of other things. And then once my NYSC was done, I took a break for like 2 months, and then I joined Microsoft right after my break. I mean, I'd already gotten the offer while I was still working there. I had just told Microsoft that I wanted to start post NYSC. So I pushed my start date to like August when NYSC was done, because I was passing out in June. And then once that was done, I started working. I don't want to really talk about my story, my journey into tech, because I feel like this is something that I talk about and it's literally all over the internet. And because of how much limited time that we have, I want to focus on the actual important things and the reason why you are at this session, which is to talk about data structures. And a data structure is a particular way of organizing data in a computer so that you can use that data effectively. And I have a really interesting example over here. This is like a collection of clothes that someone has. They've not arranged these clothes properly. So it's hard to see these clothes. And I mean, I can tell that there's a sweater here, there are jeans here, there's a polo shirt there, and stuff like that. But these clothes have not been arranged properly. So if I want to do anything with these clothes, maybe use them or make reference to them, it's going to be difficult, because there are some clothes that are under that I have to, start checking to see if I can find and things like that. And if we go back to the definition of a data structure, it says that it's a way of organizing data so that it can be used effectively. If I want to use these clothes or reference these clothes effectively, this is not a good way to organize them. However, this, on the other hand, is a pretty good way to organize them. I can look at my skirts, I can look at my shirts, I can pick them when I need them, drop them when I don't need them. The experience for interacting with the clothes have become more optimal than it would have been if I had just mumbled the clothes and kept them in the way that they are currently kept on the left. So the right is a more optimal and a better way to do these things, and the left is a bit chaotic, if you ask me. Data structures are key to a bunch of, the different engineering problems that we solve every day, and they come up in different interview questions. I've talked about how they are useful, and I'm going to use one very common company that a lot of people know. I'm going to use Uber. Uber's key engineering concept of being able to get rides or being able to get access to drivers that are around you when you need them is because they use an important data structure called a graph, and they use the concepts and algorithms for graphs they've used these concepts and algorithms for graphs to build their systems. Imagine Uber didn't implement the graph data structure, and you are maybe in Bagada, Lagos, right? And you request for a ride, and it's somebody in Mowe, Ibafo, that side, close to Ogun State, that is accepting, because there's no the closest ride to me, because the graph wasn't, implemented. So if somebody from Mowe, Ibafo that is accepting your ride and telling you, I'll be with you in 3 hours, and you want to go somewhere in 30 minutes. So the importance of data structures can't be overemphasized, and they've affected how we interact, how solutions are built, how we interact with technology, and even our lives to an extent. So there are a bunch of different data structures. I'll be talking about a couple today. But there are many on this list, and this is not even up to half, right? We have arrays, linked lists, stacks, queues, binary trees, binary search trees, heaps, hash tables, graphs, matrices, tries, B trees, NRE trees, and they're like so many. And in this presentation today, I will be highlighting arrays, linked lists, hash tables, stacks, queues, and I think I'll talk about heaps as well and graphs a little bit, depending on how much time that we have. So let's see how it goes. But yeah, let's start with arrays. So an array is a finite collection of elements of the same type. And it's important to talk about the elements having the same type, because I'll give you a real life example. If we look at, I don't know how many people here eat, let me use this biscuits, rich tea, for example. It's like the rich tea biscuits are organized in, if you want to picture arrays, look at rich tea. That's like the simplest way to put this right now. Why? When you open that rich tea pack, all the biscuits are the same. So if we're talking about elements of the same type, you have that in the rich tea biscuits. Another thing is that arrays have a fixed size. So when you open the rich tea, you know that the rich tea biscuits, like maybe the pack contains 12 biscuits, right? And the rich tea pack only has space for 12 biscuits. So if you try to put a 13th one, there's no space. If you remove one biscuit, maybe if you delete one element from the array, the size of the array is not going to dynamically change to 11 because you've removed one from 12. It's still going to be 12. It's just that maybe one element is going to be empty. So if you carry your rich tea biscuits today and you are eating from it every day, at the point, even when you finish the entire biscuits, you still have that space in the pack, right? That can only take 12. So you can think of it as the length of the array, the number of elements the array can carry. So arrays have a fixed size. And when creating an array, you have to specify the number of elements that this array has. Arrays are zero indexed as well. So meaning that if you have an array that is supposed to carry 12 elements, you can't start counting from 1, you have to start counting from 0. So what this means is that you have an array that can, your index starts from 0 and ends at 11 for 12 elements. So 0 to n minus 1, basically. Arrays are also mutable. meaning that you can change their states, and you can also change the data in the array. Like I said, the rich tea example, for example, you can eat the biscuits in there, you can put another rich tea inside, you can remove one rich tea, paint it black, put it back inside the pack, like, but that biscuit might not be able to fit another biscuit of a different shape or size, right? But you can change the state of the biscuit in there, you can change the data, things like that. I hope that the biscuit analogy was a good one and it was a good example. But that was like one way that I quickly just talk about it right now. And looking at how you can declare arrays in programming, this is how you do it. So you remember where I said that arrays have a specific size, and at the beginning of the array, you can choose to define the size. There are two ways to define the size. You can either define the size by saying, as I'm declaring this array, I want this array to have a size of 4. I want this array to be able to only hold 4 elements. Or when you declare the array, you put all the elements that you want it to have inside. And the array just knows to count how many elements are in that array and say, okay, yeah, this is the size of the array. So in this case, in this example, even if it doesn't show 4 elements, even if it doesn't show that, oh, I've said that I want this integer array to have 4 elements, I've only written 4 numbers inside. What this means is that this array has a length of 4. And as we're talking about arrays being 0 indexed as well, if we're trying to reference this array, we have to start from 0. And 0 points to the first element, which is 12, 1 points to the second element, which is 8, 2 points to the third, which is 5, and 3 points to the fourth, which is 78. So that's how, in the grand scheme of things, this works. So now I'm going to be showing you some real life uses of arrays. And the first one is that you can use arrays for API responses. When you make an API request to fetch data, if you are going to get more than one record, it will be returned as a JSON array. And when you now get a JSON array, you can iterate over the array and perform whatever action that you want to perform on that data. You can also use multi-dimensional arrays to represent matrices. So if you are solving a kind of math problem with programming that requires you to use matrices, a math problem, a graph problem, or any other, complicated engineering problem that requires you to use matrices or vectors or things like that, you can represent matrices using 2-dimensional arrays like we've shown here. Also, if you are doing something with decision trees in AI and stuff like, I think they're called decision trees, or I don't remember, decision something in AI, where you're trying to create something that can help you make that, like, you're trying to build an AI model so that based on all the decisions that you pass through in that model, and the tree that was built, the next time you pass in, I feel like I'm hearing myself echo. The next time you pass in a decision, it knows, like, the right path to follow and things like that. So you would also spend some time using arrays, dimensional arrays and stuff like that. So this is another use case for arrays in the real world. And the final way is to store data. So you can use arrays to store all sorts of data, ranging from data from a server to data in memory, or anywhere basically. If you think about social media, for example, you think about your Twitter and things like that. When the engineers make API calls to return the people that have liked your tweets, it gets returned as an array that is iterated to get, okay, this is the username of that person. I'm not going deep into the design now, of how those calls would happen and whether you are caching things or not. But the basic gist of it is that when they make a call, or when the engineer even makes a call to get the list of tweets, maybe in the last hour, things you said the last hour, it's returned as, like I said, a list of tweets. It's returned as an array, and it is now, rendered on the screen, and it is being saved. That array can now be saved maybe somewhere in memory, in a cache or something, so that the next time they want to get that thing, they don't have to go all the way to the database to fetch it. So you can use arrays to store data as well in your application's memory, on a backend database, in a cache, or in a file on your computer. So now let's talk about linked lists, which is actually one of my favorite data structures. Weird that I don't know why, but I really like to talk about linked lists a lot. Maybe because of how interesting they can be and how you can actually extend them to do multiple things. So a linked list is a data structure whose order of elements is not by their physical placement in memory. Instead, each element has a reference to the next element. Unlike arrays, that when you are doing array at position, the elements of the array at the 0th position, the 1th position, the 2th position, and the 3rd position. I don't want to say 0, 1st, 2nd, and 3rd. So I'm trying to use the number and put ch at the end. Each array element is right beside each other. So from 0, you're moving to 1, to 2, to 3, right? But with linked lists, for example, that's not the case. Me as a linked list element, I can be in my room, and the next element to me might be in Unilag, right? And I might be in my room in Lekki, and the next element to me might be in Unilag. And just because I know the address of that element in Unilag, that's all that is important. The element in Unilag might now have its next element in Shomolu or in Bagada. And as far as that Unilag element knows its address, that's all you need. So unlike arrays, they don't have to be beside each other in computer memory. All that is important is that that linked list is aware of the location of the next element, wherever it is in memory, whether it's close to it or not. So linked lists have, two important fields that people pay attention to. The first field is the data field, and the second field is the reference field. So the data field contains the data that is actually in that linked list node, the data that the linked list actually carries. That data can be anything from, someone's name to a music file to anything at all, right? Depending on whatever you are supposed to be using your linked list for. And then the reference field is the reference to the next node. So if we look at the diagrams below, we can see that node A, the data field in node A is 45, and the next reference is to node B. The data field in node B is 10, and the next reference to is node C. The data field in node C is 200, and there is no next reference, right? So we can see this, and from this we can tell. We can see this, and from this we can tell that there is no position like 0, 1, 2, 3 like in arrays. All you need to know is just have a pointer to your next reference, and you can work with that. There are different kinds of linked lists. They're singly linked lists, doubly linked lists, and circular linked lists. In a singly linked list, you are only allowed to have a next reference. So what this means is that you have one reference field that points only to the next element in the sequence. And I have talked about this in the way linked lists operate generally, where node A has a next reference pointing to node B, which is, its reference. Node B has a next reference pointing to node C. And the reference is usually the address of the next node. So let's say node A would have like the data as 45. and the reference would be something like OX0052 blah 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 blah. Like that's the address of the next node. That's why when I was using my Lekki, Unilag, and Shomolu analogy, I said I'm in Lekki. I know that the next person is in Unilag. I know their address in Unilag. Now the Unilag person knows the address of the Shomolu person, right? So when I talk about references, I mean the address in memory, exactly the exact location of that node or that data asset in memory is what we call the reference. And in a singly linked list, you're only allowed to have a next reference. Now in a doubly linked list, there's a twist, right? You have two references, not can, you have two references in a doubly linked list. One is a next reference and the other is a previous reference. So that means each linked list node has two reference fields. One would point to the next element and the other points to the previous element. So before, I've been talking only about the next element, and I said, me in Lekki, I know where the person in Unilag is, and that person in Unilag knows where the next person in Shomolu is. But in the singly linked list analogy, that person in Unilag doesn't know where I am, right? I only know where they are. So they don't have a pointer to me, but I have a pointer to them. In the single linked list scenario, that person in Shomolu doesn't know where the person in Unilag is, but that person in Unilag knows where they are. I really hope that you people understand what I'm saying. But we can leave a few minutes for questions at the end, just in case some things are not clear. It would have been nice if I could see my screen, like if I could see the charts of my screen, and then I could ask questions, but I'm sharing my entire screen, so I can't see that. But yeah, if you have questions, you can keep them till the end, and I'll definitely answer them. But yeah, that's what I mean by the pointers, right? You have the previous pointer and you have the next pointer in a doubly linked list. Now, in a circular linked list, it's a linked list with a cycle that never ends. And that's because I use myself again, the Lekki, Unilag, and Shomolu example, right? And the first time I talked about it, it ended at the Shomolu person. In a circular linked list, it never ends because the Shomolu person points back to me. So basically what this means is that the next reference of the last element would be the address of the first element, if that makes sense. So, and the previous elements of, or rather, yeah, the previous element of the first element is the address of the last element, right? So me now, for example, the last element is the Shomolu person, right? And me, the Lekki person, I'm the first element, right? 45, 100, and 200. Or rather, 45, 10, and 200, as you can see on the board. Let me use that one as an example instead of using, because at least you can see those things. The Shomolu one, the Lekki one, you can't really see. So let me use the numbers on my screen. 45 is the first element. 10 is the second. 200 is the third. In a circular linked list, 45 points to 100 to 10 as the next element. 10 points to 200 as the next element. Right? 45 is the first element and 200 is the last element. Now, the previous, if we had checked the doubly linked list, we can see that 200 does not have a previous, or rather 200 does not have a next, and 45 does not have a previous. Because in the normal doubly linked list scenario, there's the first node and there's the final node. Now, in a circular linked list, there's no first node and there's no final node, right? So what this means is that the previous of 45 is the last node which is 200. And the next of 200 is 45. So what that means is that if I was going to iterate over this linked list, it would be 45, 10, 200, 45, 10, 200, 45, 10, 200, until somebody tells me to stop talking or until my computer shuts down. But it will never end because there's no ending point. And a real life example for this type of thing is a playlist that never ends. So a playlist that continues, that if you have an album that you're playing, now let's say you're playing Ashake's album, and you get to the last song in the album, and instead of the album ending, it starts from the first song again, right? That's the example of how you would implement a circular linked list in a music playlist scenario. I hope that's clear. And this is funny because now I'm about to talk about how you can use a music playlist, or how you can implement a music playlist with a linked list. And we know that a music playlist consists of a list of songs that are played one after the other in a sequential order. The components of a music playlist are that you can list the music items. So that in a way is, how you traverse the linked list, iterating over each linked list and just, each linked list node and just putting out the different music items that are there. You can perform actions on the node themselves. So you can play or you can pause a current track. You can play the next track. So you're moving from the current node to the next node. And then you can play the previous track. So you're moving from the current node to the previous node. And you can use a doubly linked list or a circular linked list for this. If you're using a doubly linked list, what this means is that once it gets to the last song, that's the end of the playlist. But if you're using a circular linked list, what it means is that once it gets to the last song and you click next, it's going to start again from the beginning. But in this example, I used a doubly linked list to explain what I was saying, where you have a pointer from each node. Node 2 has a pointer to node 3 and node 1. Node 3 has a pointer to node 2, and node 1 has a pointer to node 2. And we can see that I tried to do this analogy thing where I put the doubly linked list on top and the music playlist at the bottom. And we can see the current track is the current node. There's a previous track, there's a next track. If you want to go back, it means you are going back in the linked list. And if you want to go to the next song, it means you are hitting next in the playlist and you're going forward in the linked list. This is how you would, show this is, a code snippet of how you would do this kind of thing in code, where you specify the linked list nodes. So you're specifying the last node and, where you specify the linked list. So you're specifying the last linked list node and the first linked list node. And these are only the nodes that you have. These are the only nodes that you have to specify, because in each linked list node itself, it has references to their next nodes. So you don't really care about itemizing the entire nodes in the linked list, if that makes sense. If you represent a playlist using a linked list, then you can have like a playlist class and a track class. So you know how here the linked list had a linked list node, and then the linked list node had like its own class, and the linked list node was also in like the linked list class and stuff like that. Here we have a playlist and we have a track class. We have those two classes. The playlist has, the reference to the first track and the last track. And in the playlist, we can add a new track to the playlist. We can remove a track from the playlist, and things like that. And the track has more information. It has the pointer to the next, it has the pointer to the previous, like a linked list would. And then it has other information like, the path to the audio, the name of the track, name of the artist, and methods that can allow us to play the track and pause the track. And if we're playing the next song in a playlist, the track is the position of the current song on the list. So if we're playing the next song on the playlist, we will do current track equals to track dot next. And then we can now play the current track. And that's how we'll do it. And if we want to go back to playing the previous song, we will do a track.previous, right? Because if we go back, we can see in the track class that there's a reference to next and previous. And these are also equally their own individual tracks. And then we can now play those tracks. Now, the next data structure I'd like to talk about is a hash table. And a hash table is a data structure that stores data in an associative manner. In a hash table, data is stored in an array format where each data value has its own unique index value. Access of data becomes very fast if we know the index of the desired data. Recently, I watched a video on Twitter. It was by a popular YouTuber. I don't actually remember his name right now, which is so weird. But he sort of did a software engineers preparing for an interview video, like it was a skit or a parody, whatever. And in that video, he was more or less, talking about, or rather acting out how software engineers only always learn about technical things. They go and read 7 million books about cracking the coding interview. And then when they entered the first interview, room, the answer to all their questions is hash map. And it was very funny because as much as it was a skit, it's kind of true that a hash table is a very important data structure, especially when you are doing lookup in computer science. When you are doing lookup, when you need to store data and retrieve data, people would always advise to go with a hash table, because when you store data in a hash map or a hash set or a hash table or any other hash kind of data structure, it's going to be very easy to retrieve that data back. You don't have to go, how we talk about time and space complexity, O of n, it takes a very long time to retrieve data from a certain data structure. It takes a shorter amount of time to retrieve, that data from a different kind of data structure. With a hash table, data information retrieval is sort of done in constant time. So it's really fast. So if you are trying to do, it's always advised that if you are trying to do any kind of, if you're in any software engineering interview and you don't know the answer to a question, and you don't know the answer to a question, and the question is about looking up data or storing data and retrieving it, always hash maps would be the first thing at the top of your mind. So now that I'm done with all my hash maps, let me just define what hashing is. Hashing is a technique to convert a range of key values into a range of indexes of an array. So what this means is that these key values are passed through a hash function, and you can now put them on a table and have those indexes there with their values, and it will be very easy for you to, hashing is deeper than just looks on the outside. There are different kinds of hash functions. You also have to think about collision, so that hashing different keys don't give you the same hash, and you don't have issues. So there are different things, but it's more complicated than that. But if you are trying to do, maybe if, for example, I'll give you this very basic interview question that is being asked, where someone tells you, going back to the linked list conversation, where someone tells you, how do you know that you have a circular linked list, or you have a cycle in your linked list, right? The most basic thing to say is that you would go over each node in your linked list and you will store them somewhere. And if I go over maybe the first node and I see student in the node and I store it somewhere, when I go to the second node, I want to check if student is already in the nodes I've found before. So the nodes I've found before should be stored in the data structure. And that data structure should preferably be a hash map. because now you are going to be constantly retrieving data, putting and retrieving data from that hash map. And like I said, information retrieval in a hash map is constant time. So it's things like that that, you should think about. So now let's talk about stacks, right? That's the next data structure that I'm going to be talking about. A stack is an ordered collection of items where every action that changes the state of the stack is done from the top of the stack. So let's talk about plates or CDs, right? If you finished washing plates and you were putting them on top of each other, it's going to be very difficult to put plates that maybe like, when you wash plates, when you wash like 5 plates and you put the first plate, then you put the second plate on top of the first plate, third plate on top of the second plate and stuff like that. When you now wash plate number 6, you can't put plate number 6 under plate number 1. You have to put plate number 6 on top of plate number 5. So what's happening is that you keep stacking plates. And the name is funny because the name also implies the action. You are stacking things on each other. And a stack is also known as a last in, first out data structure. It's a LIFO data structure because the last element put in the stack is always the first element to leave the stack. So because of this, stacks are known to be very good for reversing things. So now let's talk about the actions you perform on a stack. There are different kinds of actions that are being performed on a stack. There's push, there's pop, and there's peek. Push is when you put a new element on the top of the stack, when you add an element to the top of the stack. Pop is when you remove an element from the top of the stack. And peek is when you're not removing an element from the top of the stack, but you want to see the current element that is at the top of that stack. And so now let's push the first 3 digits, 1, 2, 3, to a stack. And initially the stack is empty. And then when you push 1 onto the stack, 1 is now the current top of the stack. And then when you push 2 onto the stack, 2 is now the current top of the stack. And then when you push 3 onto the stack, 3 is now the current top of the stack. We pushed it in the order 1, 2, 3. But what we're going to see is that when we want to pop from the stack, which we're going to be doing in the next slide, is going to be in the order 3, 2, 1. And that's why I said stacks are good for reversing things. So now let's look at popping. With the current stack, we have pushed elements 1, 2, 3 in that order. If we pop the elements in the stack, this is what's going to happen. First of all, right now in the stack, we have 3, 2, 1. If we remove from the current top, the first thing in our stack would be 3. If we remove again, it will be 2. If we remove again, it would be 1. So we push it as 1, 2, 3, and now we're popping it as 3, 2, 1. What this means is that the stack has now successfully helped us to reverse all the elements. That's exactly what it means. And I don't know how many people know about palindromes here. You know, a word like madam, a word like malam, things like that. You can use stacks, even if that's not the most optimal example, right? That's not the most optimal way to solve the problem, but it's a way to solve the problem. You can use stacks to verify palindromes. So if a word is spelled madam, M-A-D-A-M, you can spell it madam from the front, and you can also spell it madam from the back. So if you want to verify maybe in code that a word is a palindrome, you can push the word onto a stack and pop it from the stack and see if the original word and the word that you pushed and popped from the stack are still the same. right? Because its original word and its reverse would be the same if it was a palindrome. So, that's a very interesting, thing to use for a stack. And stacks are all around you. I like bread too much, so I had to put bread inside this slide. But we can see stacks of plates that I spoke about earlier, right? If I finish frying another bread or making another French toast, I'm going to put it on top of the most recent one that has been done. If I want to add another plate, I'm going to put it on top of all these plates as well. If I need to put a plate under, I need to remove the plate on top first and put that plate under. Do you understand? I can't just magically slip the plate under. It's not going to work. Something has to move a bit. I have to remove plates as well. So we can see the way bread works and the way the plate works. And as I even wrote in my slide, that sliced bread is in a stack, and you should always take bread from the top. So I'm giving side eye to people that hate the top of bread and always pass it when they want to collect their bread. But yeah, that's on the side. That's very important. So yeah, stacks are in real applications all around us, in text editors, in string manipulation, in browsers, stuff like that. In text editors, for example, how you can use a stack is with the undo button. So each action that you actually perform in a text editor is put on a stack. Why? When you press undo undoes the most recent action that you've performed, because it is supposed to remove the most recent action on the top of the stack. So it's supposed to remove the most recent state of the document from the top of the stack. If that wasn't the case, when you press undo, your whole document should clear, because it's supposed to now maybe undo to the initial state. But it's not the case. It's undoing from the most recent state, right? So stacks are what you use here. In string manipulation as well, like I talked about, the whole palindrome gist that I just gave you. And browsers as well in stacks, right? If you are going back, if you want to go maybe back to a previous page that you viewed in your browser, the pages that you view in your browser are put on a stack. So if you want to go back to the previous page, you are going back to what is you are at, the current stack. You are at the current top of your stack in your current page. If you want to go back to the previous page, what you are telling the browser to do is that you're telling the browser to remove your current state, throw it away, and the next top of the stack is the previous state, if that makes sense, right? Another example for stacks is like in debugging. There's this thing called a call stack, right? So as you write code, when you write code, your function calls another function, and that function calls another function, and maybe calls a function in the library and calls another function somewhere until you perform the actual action you're supposed to be performing. So the chain of calls is called a call stack. So call stacks are helpful in debugging, where you can see, okay, this is the first function you called, then this is the next function that function called, then this is the next function that function called, this is the next function that function called, and the next function that function called is now what is giving you your error, right? And you can see the order in which it was called and things like that. So, it's only reasonable that as we've talked about stacks, the next thing we talk about is queues. And a queue is a useful data structure in programming, as a stack is a LIFO data structure, which is last in, first out. A queue is a FIFO data structure, which is first in, first out. And it's similar to a queue in ATM, a queue for a food line, where the person that is entering the queue is the first person that uses the resource that they entered the queue for, right? So the item that goes in first is the item that goes out first. And look at people queuing in front of a Louis Vuitton store, right? So the lady in front, probably, if all is right with the world, I'm not talking about, how people are always jumping queue in Nigeria and things like that. But if all is right with the world, the first person that got to the queue is the first person that should enter the store. And the last person on the queue is the last person that should enter the store, and things like that, right? And there are different operations in a queue. There's NQ, DQ, checking if the queue is empty, checking if the queue is full, and picking. So as we have the top of a stack, we have the front and the end of a queue. The front of a queue in this case is the first person in the queue, is the lady in front over there. The end of the queue is the last person, right? And in the stack, every action is done from the top. But in the queue, you do actions from both sides. When you enqueue, you add a new element to the end of the queue. So when something joins the queue, it joins from the back. But when something leaves the queue, it leaves from the front. So enqueuing is when you are adding to the queue. Dequeuing is when you are removing from the queue. So you remove from the front of the queue, but you add from the back of the queue. Using the line as an example, when somebody is serving people on a queue food, people that are joining the line will join from the back. People that are serving the food will serve from the front. So I hope, that analogy makes sense. And this is, what enqueuing looks like. In an empty queue, the front and the back, or the front and the rear of the queue are the same. Once you enqueue one first, the first element. They enqueue the first element. The front and the rear were now 0, no longer -1, pointing to the same thing because there's only one person on the queue. When you enqueue element number 2, now the front is still 0, right? And the rear is index number 1. I'm looking at the index numbers, not the actual elements. The front is index 0 and the rear is index 1. The front would never change until, a dequeue happens. Like something is removed from the queue. That's the only thing that can ever make the front change. When something is removed from the queue. But as things get added to the queue grows and the rear keeps going back, and the line is getting longer, basically. Now in a dequeue process, when the first person on the queue or when the first element of the queue leaves, the new front in this case now, if we look here before, the front was index 1. Sorry, the front was index 0, item 1, right? When a dequeue happened, when item 1 left the queue, the front now became index 1, item 2. And the line has now become shorter. So that's how, dequeuing happens and stuff like that. The goal was to spend an hour talking about this and then, reserving the rest of the class for questions that people might have and things like that. But yeah, there are other data structures. There are graphs, there are tries, there are heaps, there are so many. There's so many data structures. In the beginning of this class, I sort of talked about graphs and how Uber uses graphs. Tries are, data structures that you can use for autocomplete. So if you think about how maybe Google or Bing search, all these people that have autocomplete implement their autocomplete. The basic gist of it is that there is a state, there's a state tree somewhere called a trie, right? And that's, does the autocomplete for them. Heaps are, a kind of tree as well, where all the elements up are either higher than all the elements down, or all the elements down are either higher than all the elements up, things like that. And there are many more data structures. We've talked about the fundamentals of the basic data structures, and I was told that I was supposed to give a take-home assignment. So I would like you people to do research on graphs and tries, write about them, what their time complexities are, and how you can use them in real life, the differences. And I think I've even given you both. I've given examples for both of this already, but I would like if you did not use my own real life applications, and you came up with yours based on what you did in your research. At this point, I'm open to taking questions. If there are any questions for me, thank you so much. And again, apologies for joining this really late. There's a bunch of chaos happening and I had to, be in the middle of some of them, but open to answering your questions right now if you have any.
Yay, that was awesome. Thank you so much, Adora. Thank you so much. Like, I almost fell asleep because your voice was so soothing and it was so calming. It was super calming. Give me a minute. Give me a minute. Give me a minute. Yeah, Ada, so that was for you actually. Thank you so much for breaking down the data structure concept. Like you broke it down like, well, even me that is not even a software person, I still understood like what you were saying with the real life example you were giving, right? So thank you so much. And yeah, we accept your apology. Okay, that being said, there's a couple of questions here for you. So I initially shared a Slido link where learners can share their questions. Let me reshare. Yeah, let me reshare. So but I'm just going to quickly read out here. So I don't know, is this a question? But someone is asking which data structure is used in a phone book. Is that is that a thing?
In a phone book, okay, so let me open the phone book on my iPhone.
Okay.
I think it's just a list, right? Or it could be, I know that there are data structures that, arrange things as you put them in. I think those are sets. Sets are like that you can't have. So a set is that you only have one instance of that thing. So you can't have like 5 2 times in the same data structure. There are some data structures that where as you put things inside, they sort of are arranged alphabetically, if that makes sense, right? I don't remember the name right now. It's a kind of list though. But yeah, that's definitely what you would use. Because what?
I don't know.
Oh, don't worry, that's not you. Let me mute him.
Okay. Because if you notice, when you look at your phone book, it's always arranged in a particular order. So let's actually Google this quickly. Data structure arranges items in order. I don't know why I feel like it's a set, but I might be wrong. Like a data structure that's sorts in place. So it's giving me sorting algorithm, so I might not Googling it well. Data structure used in a phone book. Let me just ask the question the way it is and see what Google will tell me.
All right.
Someone is saying that you can use a try in a phone book. Oh, I see. I can see why somebody would want to use a try in a phone book because of the autocomplete part of the phone book. But I'm thinking about what they call it. When I was answering your question, my approach was listing the phone numbers and contact names. But for the autocomplete part, I understand why they want to use a try in the phone book. But for the listing parts, I think you're going to use multiple data structures to implement. Like you would use the try so that you can do the autocomplete and search thing properly. But for the listing out, the items, I think there's a data structure that allows you, like when you put things inside, it automatically sorts it. I don't remember the name right now, but I know that there's a structure like that exists. However, a try is also valid for the searching parts in the phone book And if for whatever reason you are trying to implement a phone book and you don't remember the data structure I'm talking about, you can just use a normal list and then have a certain algorithm that when you add a new contact, that's not an optimal solution though. When you add a new contact, it should sort, like it should resort the list in place. I hope that makes sense.
Okay. So Adobe is asking, so data structures and algorithms seems to be a mirage to me, as I'm still struggling to better understand linked list, stack, queue, etc. Please, what is the best way? I think Ada is seeking an advice from you, Adora.
The best way is to start with, first of all, open your mind. You say that you're struggling, and I know that it's hard. I'm not going to lie, especially in the beginning, especially, for people that don't have that fundamental computer science background. But what I tell myself when I want to learn anything in this life is that the people that are doing it, they are not better than me and they don't have two heads. So if they are doing it, me too, I can do it. It might just require more time, more dedication, a little bit more effort from me, but it's possible. So that's the same thing that I want to tell you, right now, is that it's possible. You might need to open your mind a little bit. Find resources that explain this thing to you in the most basic way possible. I know that there are many fundamentals of computer science courses. I know there's the Harvard CX51, there's MIT OpenCourseWare. There are a bunch of them, right? Find them, take them. If they don't make sense after, join all these communities where people, solve these problems together. And I have one at the moment right now. There's an ongoing cohort for my study group led by Ayomide. I don't know if you know Ayomide. He works at Google in Ireland, leading the data part of it. So he has like a data structures. He'll be doing it in cohorts right now. So I think this cohorts, like they've applied and they've already, started the boot camp and stuff like that, right? So I might not be able to join this one again, but you can still join the Slack and, because people there drop data structures questions, they solve it together. And that's a good way to, just hit some people up, ask them, oh, I'm trying to solve this data structures problem. Can somebody help me? Even if there's no ongoing class, somebody in that Slack will see it and be willing to help you. So community learning is another thing, but finding resources that, explain this thing to you very easily is equally another thing that can help you learn.
Yeah, thank you so much, Ada. I think I really agree with the CS50 course. When I was also starting out, I remember taking that course. I mean, it was a whole lot because, the number of hours, but if you dedicate your time to it and, just, give it ample time, you would definitely grasp a whole lot. And it was really simplified. That was one thing I loved about it. And yeah, again, follow up Ada on Twitter, on LinkedIn. I'm sure you definitely get to know when the other course will be starting. I guess Adora Hacks. Yeah, I think that's the name. So yeah, I've been following Ada for quite a while now, and she's really amazing. She does a whole lot of things for free for the community, and that's really, really amazing thing to do. So Ada Obi is still asking, I have interest in cloud computing and I find your book, Cloud Engineering, quite helpful. I'm currently learning with GCP. Oh, GCP, Google. Okay, please, what do you advise? Okay, another advice again.
Question again.
Should I go over it again?
Yes, please.
Yeah, sure. So Adobe is asking, I have interest in cloud engineering. She has interest in cloud engineering and she has found your book and she thinks it's quite helpful. And she's currently learning with GCP console. Please, what do you advise? She's also asking for an advice from you.
Learning GCP.
Yeah, with GCP console. That's what she said. But okay, yeah, that's true. Adobe, what advice exactly?
Yeah. Because I don't use GCP, right? I don't know how exactly it works and all of that. So
I don't know.
So
okay, Okay, Adobe, can you just unmute your mic for a while to just, quickly say what, like, the exact help you need now or the advice you need from Adora? Is Adobe still on the call? Hi, Adobe. Okay, all right. I don't think Adobe is on the call, so we'll just move on. So Anonymous is asking, how can a non-computer related graduate that loves programming makes his way as a software engineer since priority is given to computer related graduates? Okay.
How can a non-computer related graduate make his way as a software engineer? Although there are many computer science graduates, working in software engineering and tech and all of that, there are many non-computer science graduates that are also working in tech and doing pretty well. One of my friends, she works in Microsoft in Canada. Well, she was working in Microsoft in Nigeria before she left, because Jackpa. She left Canada now. And oh yeah, Adobe, even if you can't speak, you can ask your question in the chat. Like, you can type out what you mean. Okay. I'll get back to your question. She has, explained it now in chat, so I can see it. So yeah, the non-computer science thing, I think sometimes it's something put in your head. At the end of the day, the most important thing is the value that you bring. The reason why these companies ask for computer science graduates is not because of the paper. It's not because of the pali. Nobody cares about the paper. The reason why they ask for computer science graduates is because they feel that computer science graduates have gone through the system of learning the fundamentals of computer science. So it will be easy for them to pick up any tech thing in their jobs as they grow in their careers. As the way they teach non-computer, like many boot camps, the way they teach non-computer science graduate things is they will teach you JavaScript so I can get your first web development job. But you don't know the fundamentals of things to carry on if you don't, burn that midnight candle by yourself and learn things. So as a non-computer science graduate, if you can prove that you've learned the fundamentals, it's the fundamentals that count, whether you learn them in a structured school with a degree or not. If you can prove that you've learned the fundamentals, you go into any interview and you kill it, you will be hired regardless of whether you have that degree or not. So, and that's why nowadays I'm investing most of my time, as opposed to teaching Azure. I mean, I still teach Azure, don't get me wrong. I will still teach Azure. I will still teach, a bunch of all these platform specific things. But however, nowadays I invest more of my time teaching fundamentals. I want to teach data structures, fundamentals of programming, thinking about systems design, how you should answer interview questions, because these things are fundamental computer science things that many people are not really teaching. Everybody's learning React, everybody's learning Vue.js, but not so many people know at its core how JavaScript works or even the DOM. Do you get what I mean? So having that fundamental, and the reason why companies would lean towards computer science graduates is because schools teach you that fundamental knowledge. But as a non-computer science graduate, if you want a career as a software engineer, learn that fundamental knowledge and join communities, apply to these companies, and you get hired at some point. I know that it's possible.
Well, thank you so much for answering that. Made mention of defining the size of an array. Your talk. How do we specify the size of arrays?
I'm just going to type it in the chat.
Oh, okay.
When you are declaring the array, that's how you type it. Like, that's how you specify it. So I'm going to name this array my array. When you are declaring the array, so I'm declaring an array, an integer array that has a size of 4. This is all you do. So you create the array, then you specify that it's an array, and you put the length. I mean, like this vary depending on the programming language that you're using. So These are things that you can find
Right.
in the definition of the programming language. So I wrote it in the way that Java, like object-oriented programming languages, the old ones, then Java and C# would do it. You would specify it differently in JavaScript, you would specify it differently in Python, right? So there's no one size fits all way of declaring the size of an array. The fundamental thing is that with arrays, you always declare the size. And that's why, like I said, it's important to learn the fundamentals. Once you, depending on whatever programming language you are writing, know that, yes, if I'm creating an array, I should declare the size. And then you can just go to their documentation and check how to declare an array in that language.
Also, hi Anonymous. I really hope you're able to like see the chat and see what Adora types in there. So someone else is asking also data for a Node.js engineer. So the person is asking between objects and arrays, which one is perfect for storing data for a Node.js engineer, like as a Node.js engineer, which is better?
That's not a question. Like I can't sit down and tell you always use objects.
No, I know, right? Yeah.
Depending on the code you are writing, that would inform where you should put your data. If you are storing details for a particular thing, for example, I'm storing details about a human being. I want their name, I want their address, I want their name, I want their height, their weight, their favorite color. I can store those things as an object. If I'm storing data about multiple people, or if I want to store a list of names or a list of colors, I will store it in an array. So I don't know why this is a question. I think the person that asked this question should take some time learning about computer science fundamentals more before they start writing JavaScript. Because if you knew about computer science fundamentals, I don't think you would be asking this question.
Okay. I mean, I hope the person was able to hear that. I mean, you can always pick up the CS50 course. It's on YouTube and it's free to watch. Just it's a lot, 20 hours, but bit by bit you'll be able to like finish it up. Okay, I think that's it for the question on Slido. So you can as well go ahead to answer.
Yeah, so let me just quickly answer Adobe's question.
Give Ada will be the advice she. Yes.
Yeah, so let me just go ahead to answer Adobe's question. She said she wants general advice for people learning cloud computing. I don't know what general advice means because you didn't ask for like specific things. But I would say even if you are learning cloud computing, you should learn cloud computing. You can use GCP to learn cloud computing. Yes, that's good. But make sure that you are learning cloud computing and not GCP. If you get what I mean. Make sure GCP is the tool that you are using to learn cloud computing, but you are not learning GCP. Because what that does is that when you just learn about that particular tool, you box yourself. You box yourself into only doing GCP work, and you're not able to use AWS or use DigitalOcean, which should not be good for you. As I am right now, I know a lot about cloud. I've only used Azure in my life. Well, and a bit of DigitalOcean, but mostly Azure in my life. But if tomorrow someone says, okay, we are hosting on AWS, I will not, because I know the fundamental things and I just know that the platforms are platforms. They still, at the end of the day, offer the same services. It's just different names and the website is different. And the maybe programming language or scripting languages and things like that are different. But all in all, fundamentally, it's kind of the same thing. So as you are learning GCP, make sure that you are also just not learning the terms that, and how they apply in GCP, but generalizing them to know that these are general cloud concepts and broadening your mind to learning deep about the cloud in the process. Yeah, join cloud communities as well. I tend to see that. You're welcome, Adobe. Join cloud communities as well. Twitter spaces where people are talking about cloud. I've seen that these things tend to help a lot. Um, so it's something I would definitely advise you to join if you had the chance to, listen to them and stuff like that. Yeah.
Okay. Okay. All right. So thank you so much, Adora. Thank you for answering that question. So I mean, that's all from the learners, but I personally have a few questions for you, right? So I wanted to know, I think this is also going to benefit the learners on the call. So as a software engineer, what do you think employers look out for when trying to
As a software engineer, what do I think?
software engineer?
Um, I tell this thing to people. If you are applying for a job and you have everything needed for that application, you should not be applying for that job. You should be applying for a job a level higher than that job. And recruiters know this. People that hire know this. I mean, I'm a software engineer, but I've also interviewed people, in my office before and things like that. So this is me talking from a place of experience, right? For a software engineering interview, especially as a beginner, what's important is that you know the fundamentals. What's important is that you have an open mind. Like, you're someone that wants to learn stuff. You are someone that can collaborate, and someone that is inquisitive, wants to ask questions and stuff like that. You're a good, you possibly be a good team player, a good member of the team. You are someone willing to learn, and you have the fundamental knowledge that can be built upon. And you are someone that can add value, maybe because they've seen that maybe you've done one hackathon somewhere, or you've written one code for your portfolio somewhere, things like that. So nobody is expecting that. When people say you should have many, many, many years of experience, is because they know that those years of experience have come with, value that you've added over time. But if you can show value that you've added, even without the experience, and you can also show technical fundamental knowledge or know-how, people will still listen to you and give you a chance.
Okay. Thank you so much, Ada. So I think I have one more question. So you do a software engineering portfolio. What do you think it should contain?
A software engineering portfolio.
I know you probably will not have sorry?
A software engineering portfolio should contain things about you. It should contain things about you, things that you are interested in, things that you are learning. And it should also contain work that you've done. So if you've written code, maybe it should contain a link to your GitHub for all the code that you've written, right? Libraries that you've built, open source contributions that you've made, if any, talks that you've given, ways that you've added value are things that you should definitely highlight in your portfolio. So I would say your portfolio should have two things: things that you are interested in, and ways that you've added value. So you can add value in terms of talks you've given about something, volunteering that you've done, just contributions that you've made, a library that you built with your friends, a hackathon that you were a part of, even if you didn't win. And I'll tell you, please, 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 anywhere you see hackathon, just be applying, especially when you're a junior person. Because what hackathons do for you is that they put you in that space where you have to work with people and you have to build something in a short time. And what that helps you do when it comes to recruiters is that they see that you are someone that can work with people. You are someone that has actually built something. You are someone that can add value. So maybe the reason why you have not added value in corporate organizations right now is because somebody has not given you a job yet. Do you get what I mean? But they can see that you have something to offer. So anyway, you see hackathon, put your face inside there. I'll tell you for free.
And also I know section she does. I mean, she just concluded one recently. You guys can look her up. She's also a software engineer at Microsoft. And look at okay. You can look at this master classes. It's always free. I mean, I think for now, but I mean, because those are so much value for it to be free. So now that you can, please follow her up, put your CV together and all. So do you also want to talk about how to set yourself apart, from the crowd, as a software engineer, Adora?
I think I already have talked about it when I'm talking about what recruiters see. Project the value that you offer and project the things that you are interested in, right? A lot of people come into maybe either looking for tech jobs or trying to get tech opportunities or things, or trying to join a community with what they can gain from it. But people hardly actually even think about what they can give. Give to the community, and people will start looking for you to hire you, to spotlight you, to like. I mean, she has mentioned in this conversation, I'm here having this conversation with you guys, right? Because I was found, because I give, right? Mary Blessing has also mentioned Chiso, that does these free master classes for you, like putting your resume together and job applications and stuff like that, right? She's giving to the community, and because of that, people are looking for her. Do you get that kind of thing? Nobody is going to like wait for you to come and, how do I put this? Nobody is going to wait for you. Do you get it? You have to find a way to create things for yourself, add value, and that value is going to make people come and look for you for multiple things. Look for you when they are recruiting, look for you to spotlight you, look for you when there are multiple things that have to be done. Do you get what I mean? Like, so project your value and also contribute to communities. I've seen how community contributions has changed many people's lives. I'm going to use Ruthie King as an example as well. Ruthie King, sorry.
Oh, our good top star. She's coming to talk to the learners very soon.
Right? And we've seen how Ruth's contributions to open source has legit changed the trajectory of her life. And I think she's like she's young. Do you get what I mean? Like, Ruth is a small girl.
Yeah.
She's no longer a girl. She's not a woman. Do you get what I mean? So, these things are important, and you should take them seriously.
Like, seriously, guys, like, I agree 100% with what last night a friend reached out. I was like, someone is recommending me to a community management role. I'm like, oh, I already have one. They're like, oh, that they did not know that the person was, that it was like the community I belong to, like, and how I've been like helping, the community, people in the community, help them like navigate their way around tech. I mean, I don't know much, but I could just push resources to you, tell you go and meet this person, follow this person, and stuff like that, right? So community contribution can take you places you would never ever imagine. I hear Ruth talk about her stories every time. I'm like, you must come talk to my learners. And she's coming on the 23rd, guys. I hope you are ready for her. So thank you so much, Adora, for mentioning that. And yeah, that was I think we have one more last question. I don't know who is putting this question, but I think this is going to be the last one. So, is coding along project tutorials a good way of becoming a software engineer? Hi, Adora.
Coding along with project tutorials. Of course, when you are learning, yeah. But when you finish that project tutorial, please go and build another project.
Right.
Yeah. So yes, of course, like, because I mean, code along. Don't just watch the tutorials as you are learning. Code along. But when you are done, build something. And I always advocate for building something in teams. So try and build something with a group of people, join a hackathon, make an open source contribution, like work with people, because what you're trying to do is you are preparing yourself for the job that you actually want to get. And the job that you get, you would never work alone.
You never walk alone. Oh, I asking a fan here. All right. Also, I mean, like this section was really, really honoring our invitation. Thank you for coming to speak with the learners. Thank you for sharing your knowledge. And I see they actually enjoyed it. Hey, okay, Liverpool. Okay, thank you. So I see they really enjoyed, like they've been enjoying their time so far with you. Like it's really an honor, Adora. Thank you so, so much. Please, you have a final word for the learners here, and we'll be wrapping up this section.
My final words, just go and add all the value you can, contribute, give, and just watch the entire tech ecosystem favor you.
Also, like that was straightforward, but guys, that's really powerful because that's majorly all you need. Go, excel, contribute as much as you can, and honestly, the universe will just find its way to align to your, for your own good, right? So yeah, thank you so much, Ada. And 1 minute.
Thank you. Thank you so much.
Thank you so much, Ada. So guys, we are done with this section. I hope you go follow Ada. I want you to follow Ada really. Have shared her link to her LinkedIn profile and that of Twitter. Please go follow her, keep up with her stories, and say thank you whenever you see her, and hug her. She's really beautiful, guys. I keep saying that. So, Adobe, thank you. Thank you. I'm a huge fan. So guys, I'm just going to continue playing my songs, and I hope you have a wonderful evening, Ada. I hope you have a wonderful evening, everyone. Bye. So guys.
Thanks, everyone. Thank you for having me. Enjoy the rest of your day.
Yeah, thank you.